Okay, quite a challenging question. Our strategy will be to use force diagrams, get equations, as many equations as we can from each force diagram, and juggle those equations until we get an answer. So I'm pushing my mower with a force, and there's 30 degrees in there. Clearly there's a normal, a weight, and a force of friction going opposite the way that I'm pushing. It says in the question that I need to push 3 times harder, so I'm going to put a 3 there, so I've got a common F between force diagrams. Okay, let's see how we go. I've got 1, 2, 3, 4 vectors, and I'm just going to add them together and make them equal to 0. They're equal to 0 because my net force is 0 because I'm mowing at a constant speed. Okay, so vector 1, and clearly I'm going to be struggling to fit this in one line, so we'll see how we go. Really important we use 210 there, because that's the angle from the positive x-axis around to our vector, plus 0n plus, let's do the weight one, and I'm going to fit this in only just force of friction 0 equals 0. Okay, let's pull out the x components. Cos 210 is root 3 on 2, so it's going to be 3 root 3 on 2f, and it's in quadrant 3, so it's a minus. Then we've got plus 0 plus force of friction. So let's just neaten that up. So we can say the force of friction will equal multiplied by the force that we're pushing with. So that's an equation. We've got one out of the way. Let's get the y component out. It's going to be minus 3 on 2f. And I can go normal equals there's another equation. Okay. Now there's a link between our force of friction and our normal. Force of friction equals mu n, and mu is the thing that the question is asking for. So we've got to get that in there. So there's our force of friction equals, must equal that. So I'm going to go 3 root 3f on 2 must equal mu times n, and n is that thing there. 3 on 2f okay. Let's just neaten that up a little bit. I'm going to multiply everything by 2. I'm also going to expand my bracket. So that's going to be 3 mu f plus I'm going to get that 3 mu f to the other side. Factor out the f, and then get the factor on the other side. In fact, I might do that in red. Okay. So I want to do exactly the same, but now I'm going to be pulling. There's my normal, there's my weight. Now because I'm going that way, the force of friction, really important, I'm going to get this read. See that normal and that normal, they're different normals because the normal is dependent on the forces that are applied. So you can't get those two ends are different ends. Okay. So we're going to go again. So first force is F cos 30, F sine 30. Then the N is going to be 0N plus 0. It's my weight plus. And this force of friction over here that we're going to add in, it's actually an angle of 180 degrees. And clearly it's acting in the negative direction. It's going left, it's not going right, and right is positive. So that's minus the force of friction over there. If we don't do it exactly right, it just won't come out properly. Okay, so let's get out our x components. F cos 30 is root 3 on 2 plus 0. Oops. So our force of friction equals, so again that's an equation. Let's pull out our y's. That's going to be and n will equal same thing. I've got force of friction equals mu n. I've got my force of friction and my n, and the mu is the connection between those two things. So force of friction we know is root 3 on 2f from that equation, and that will be the same as mu n, and we've got n from in here. Very similar to the last force diagram, and same as last time, I'm running out of room. So let's multiply by 2 to get rid of the fraction and also expand that mu into that bracket. 19, is it? 19.6 mu b minus mu f root 3f plus mu f. Let's just put that in there. Let's factor out that f. And let's just get rid of it. There we go. Okay. That was a bit of a cheat. Sorry, running out of room. There's our red box with our f. And there's our red box with the f. So it sort of makes sense that those f's are the same. So I'm just going to set that equal to that because they're the same f. And let's see if we can get a value for mu. So 19.6 3 root 3 minus 3 mu. So there we have it. We still have some unknowns, but if you look at it, those b's are the same. So if the betas, I'm dividing both sides by beta, and they will actually just cancel out. I'm also going to divide both sides by mu. They cancel out, and I'm going to divide both sides by 19.6. And they cancel. I'm going to get that bracket to the top by multiplying it. 3 root 3 minus 3 mu. And then I'm going to get that side to the top by multiplying both sides by root 3 plus mu. Some people call that cross multiplying. If you want to call it that way, that's fine. Okay, and all of a sudden we just want to get mu equals. So I'm going to take mu to that side. 4 mu equals 2 root 3. So mu will equal 2 root 3 on 4, root 3 on 2. There we go. It's all about the force diagrams and juggling equations, like any good question is.